Hi, good morning everyone. Today we are going to discuss about Kirchhoff's law, that is Kirchhoff's voltage law. In a previous video, we have discussed about Kirchhoff's another law, that is KCL, that is Kirchhoff's current law. In this video, we are going to discuss about KVL, Kirchhoff's voltage law in our subject. Come, let's get into the topic. So Kirchhoff's voltage law is also called as Kirchhoff's second law. According to Kirchhoff's voltage law, the voltage around a loop equals the sum of every voltage drop in the same loop for a closed network and equals to zero. So, in a different manner, put differently, the algebraic sum of every voltage in the loop has to be equal to zero, and this property of Kirchhoff's law is called as conservation of energy. So, this is KVL. So, in a simple way, it's Kirchhoff's voltage law, that is KVL, which is nothing but in a closed path, potential rise, the sum of potential rise equal to sum of potential drop. That's the Kirchhoff's voltage law. So you look at the diagram. In this diagram, there are four corners. That's A, B, C, D. So where there are some voltage drop, that means sum of all to voltage drop around the loop is equal to zero according to the statement. Here, in the point between A and D, there is one resistor, and A to D there is another resistor. B to C one resistor is there, and D2C is another resistor. So between these two terminals, there are some resistors which, because of this resistor, there are some voltage drop occurs. So that would be taken as VAB plus VBC plus VCD plus VDA. So sum of all those things which is equal to zero. This is Kirchhoff's voltage law. So when you begin at any point of the loop and continue in the same direction, note that the voltage drop in all the negative or positive directions and returns to the same point. It is essential to maintain the direction either counterclockwise or clockwise. Otherwise, the final value, voltage value will not be zero. The voltage law can be applied in analyzing circuits in series. When either AC currents or DC currents circuits are analyzed based on Kirchhoff's current law, circuit law, you need to be clear with all terminologies and definitions that describe the circuit components like path, nodes, mesh, and loop. So this what is path and what is node and what is mesh and what is loop, everything we discussed in the previous video itself. So here in this circuit diagram, in the given example, there is one voltage source V, and there are two voltage drop mentioned as V1 and V2. So this is a one closed path, so it is can be considered as a loop. According to the KVL, so minus V, that is potential rise, minus V plus V1 plus V2, which is equal to zero. So let us see one example. Here in a given circuit diagram, there are three resistors and two voltage sources. So the three resistors value which is given as R1 which is equal to 2 ohm, R2 4 ohm, and R3 6 ohm, and two voltage sources namely called as E1 and E2, which is given as 10 voltage and 5 voltage respectively. So for this given circuit diagram, we have to determine the electric current by using KVL. So, how come, let's see how the electric current we can determine from the given circuit using KVL. So, the solution, the following are the things that you should keep in mind while approaching the problem. You need to choose the direction of the current. In this problem, let us choose the clockwise direction. When the current flows across the resistor, there is a potential decrease. Hence, V equal to IR is signed negative. If the current moves from low to high, then the EMF E source is signed positive because of energy charging at the EMF source. Likewise, if the current moves from high to low voltage, that is positive to negative, then the source of the EMF E is signed negative because of the emptying of the energy at the EMF source. In this solution, the direction of the current is the same as the direction of the clockwise rotation. So, minus IR1 plus E1 minus IR2 minus IR3 minus E2, which is equal to 0. So substituting the values in the equation we can get. So minus 2i plus 10 minus 4i minus 6i minus 5 equal to 0. So altogether when you simplify this one, we will be getting minus 12i plus I 5 equal to 0. So I obviously minus 5 divided by minus 12. So I equal to 0.416 ampere. The electric current flows in the circuit is 0.416 ampere. So what's the conclusion here? By applying the Kirchhoff's voltage, that's the second law, we found the current value inside the loop, inside the circuit loop. So the main motto of using the KVL is to find the loop current. Thank you.